So this will be our last topic in the chemistry unit. The mole equation and the mole as a unit of measurements. Okay? So the key points for this lesson are that we understand the mole is a unit for measuring a number of particles. Okay? Because atoms and molecules are so small, it's impossible to count them and then say, I have 420 gajillion, atoms of hydrogen. Okay? We can't do that. It would take a lifetime to count to that number. Okay? So we have to have a representative number. That representative number is the mole. The mole is like a dozen. A dozen is always how many? 12. Doesn't matter whether it's eggs or donuts or oranges, it's always 12. If someone tells you that they have a dozen eggs, you know it's 12. Okay? And if they say they have a dozen donuts, you still know it's 12. A dozen is always 12. Well, a mole is always this many. Unfortunately, not 12. 6.02 times 10 to the 23. That's 602 with 21 zeros behind it. It's a lot. Okay? Again, these are very small things that we are dealing with. It would be impossible to count them. So we needed a number that was representative of a certain amount of particles. Now you're probably looking at that number and went, okay, so who did count that? Okay? Well, it wasn't a matter of counting, and it's not a random number either. It seems like it, okay? But it's not a random number. A guy named Avogadro came up with this idea. Okay? He knew that he needed some sort of unit that could talk about the vast numbers of particles that would be involved in chemical reactions and things like that. So he said, I'm going to base this number on the simplest atom we know, hydrogen. We know that hydrogen has one proton and one electron. It's a very, very simple atom. He said, so what I'm going to do is, since I know the mass of one electron, and I know the mass of one proton, or at least they had an idea, okay, of those, said, I'm going to figure out how many particles of hydrogen are in 1 gram. And then that is going to be the number I use for everything. Okay? So he did the calculations, did the figuring, and he found that in 1 gram of hydrogen, there are 6.02 times 10 to the 23 atoms of hydrogen. Okay? And then he said, all right, that's my number. I'm going to call it the mole. I don't know why. Actually, I do know why. You'll see when I show you a picture of him. Okay? So he called it the mole, and then that's used for everything else. Now, when I have 1 mole of hydrogen, its mass is just a hair over 1 gram, because that's the one we use. Okay? If I have 6.02 times 10 to the 23 atoms of lithium, it has a mass of 6.941 grams. Why is the mass of this many particles of lithium greater than this many particles of hydrogen? It's sort of density. Okay? Remember on the first day when we talked about how the properties of each thing are related to how many protons are in the nucleus? How many protons are in the nucleus of a lithium atom? 3. Okay? And if we look at the molar mass here, in an atom of lithium, in 1 atom of lithium, there are 3 protons, there are 4 neutrons, and there are 3 electrons. The atoms of lithium are bigger. So when I have the same number of lithium atoms, this many, as I have hydrogen atoms, which only have 1 proton and 1 electron, naturally, it'll weigh more. Okay? Or I shouldn't say it that way. We'll have more mass. Okay? Because they're simply bigger. Right? And you can see that pattern holds true all the way along the periodic table. Okay? The numbers, the masses get bigger and bigger and bigger as the atomic numbers get bigger and bigger and bigger. Okay? The atoms are getting bigger, so the mass of that many atoms obviously is going to be greater. Is everybody okay with that idea? Okay. The next thing we got to understand is the relationship between moles, mass, and molar mass. That's going to involve using the mole equation. N equals little m over big M. See, chemists don't have a lot of creativity. So they made a 3-variable formula that has the same letter in it twice. And the only other letter that's in it is the one that sounds like the letter they used twice. N equals m over m. Very confusing. You could have picked better letters, but whatever. Okay, so N is the number of moles. Okay, and remember, a mole is like a dozen. So if I told you I had 4 dozen donuts, you know I have how many? Don't say 4 dozen. 48. Okay, if I had 48 moles, I'd have 4 times that 6.02 times 10 to the 23. Okay, little m stands for mass. Okay, and that's in grams. And big M stands for molar mass. Okay, and that's in grams per mole. These atomic masses on the periodic table, those are molar masses. Okay, that is the mass of 1 mole of that element. Okay, so any one of the numbers you see on your periodic table, that is the mass of 6.02 times 10 to the 23 atoms of that element. Okay, that's the molar mass. Everybody okay with that so far? So we'll be learning how to use this formula. We're going to review how algebra works. Sorry, this is number of moles. Okay, that's not hashtag moles. That symbol stands for number. Okay, number of moles, not hashtag moles. All right. So we're going to review a little bit of algebra. Okay, because I know lots of people come to me and they don't know how to do that. They don't know how to manipulate equations. They've been taught tricks that are terrible, and I'm going to have to undo that, and that's fine. Okay? I can teach you how to do algebra. It's super easy. All right. So when we are looking at a certain amount of a substance, we can talk about that amount in a number of different ways. We can talk about its mass, and we can say its mass is 25 grams. Or we can look at its volume, and we can say there's this many cubic centimeters of that material, or this many liters of this material. Okay? There's all kinds of different ways to express the amount of something. But when you're looking at it from a chemical standpoint, and you need to start dealing with the number of particles, again, you need that representative number, the mole, 6.02 times 10 to the 23 particles. Okay? I want to give you an idea, so you can kind of fathom the size of that number. Okay? That number is huge. And when I have that many hydrogen atoms, it only has a mass of 1 gram. That's about the mass of a raisin. Okay? So in the mass of a raisin, if I had 1 gram of hydrogen gas, okay, it would have that many particles in it. Okay? To give you an idea of just how small atoms really are. Okay? There's a lot of them in an incredibly small amount of stuff. All right, so this is Avogadro's number. Okay, Avogadro's number, okay, is 6.02 times 10 to the 23. You do not have to memorize that number. It is on the back of your periodic table, okay, along with some other constants that will be useful throughout the course. Okay, but that's Avogadro's number. The mole equation, also, you don't have to memorize that. It's on the formula sheet part on the back of your periodic table. Okay, everybody all right with that idea so far? Okay, we kind of already talked about that. Let's just quick review. So the mass of 1 mole of a substance is that substance's molar mass. Okay, so as we were saying, if I have 6.02 times 10 to the 23 atoms of hydrogen, it'll have a mass of 1 gram. That's its molar mass. Okay, if I have 6.02 times 10 to the 23 particles of lithium, it'll have a mass of 6.941 grams. That's its molar mass. It's the mass of 1 mole of that material. Okay? Now, that's all well and good if you're looking at elements. I can just look them up off the periodic table. What do I do for compounds? Add them up. Exactly. Right? So if I'm looking at something simple like water, okay, I have to add up the molar masses of the materials that are in there. And I have to reflect how many of each one there are. There's 2 hydrogens here. The molar mass of hydrogen is 1.01 grams per mole. But there's 2 of them. So I would multiply that by 2. And then I would add that to the molar mass of oxygen, which is 16 grams per mole. All right? So that'll be 18.02. And that'll be grams per mole. How important are units? Very important. Okay? If you just write 18.02, that could be apples, it could be oranges, it could be elephants, it could be old ladies and walkers. I don't know. Okay? You have to have units on there, otherwise the answer is meaningless. Okay? Units are very, very important. All right. What about if I wanted you to calculate the molar mass of this stuff? Okay, how many nitrogens are there in this compound? 1. Okay, molar mass of nitrogen, 14.01 grams per mole. How many hydrogens are in this? How many? 3. Okay, so I'm going to go 3 times the molar mass of hydrogen, which is 1.01. So I'm going to get 17.04 grams per mole. I think that's right. I did that in my head, which is dangerous, but I think that's what it's. Okay. Is that terribly hard? Not terribly. Okay. Now let's give you one like this. How many nitrogens are in that compound? 2. Right, okay, there's brackets around this. Multiply everything inside the brackets by 2. So 14.01 times 2. Okay, plus how many hydrogens? 8. Okay, 4 times 2 is 8. So 1.01 times 8 plus sulfur, 32.06. 32.07. Okay, and there's only 1 sulfur. All right, so now I would add those together. So 28.02, 36.1, 68.17. Who needs a calculator? Me. That's who. I shouldn't do that. Okay, and what's wrong with that? No units. What are the units? Grams per mole, because this is the mass of 1 mole of ammonium sulfide. Okay, everyone kind of following how to do that? Okay, it's not terribly difficult. It's a little bit of multiplication and a little bit of adding. Okay, you just have to look up your periodic table. All right, I want you to try those 5. Okay, let you get ahead of me, and then we'll walk through them together. All right, let's have a look at the first couple here. So for number 1, we've got sodium and chlorine. How many sodiums? 1. So 22.99 grams per mole. Plus 1 chlorine, 35.45 grams per mole. I'm not going to do that in my head. All right, 58.44 grams per mole. All right, and then for number 2, we've got iron 3 bromide. So the iron's 55.85, I believe, and bromine is 79.90. Is that right? Yeah. Okay. And there are 3 of them. All right, so we're looking at 295.55 grams per mole. All right, give you a little bit more time to get ahead of me there. Okay, let's have a look at number 3. So we got diphosphorus pentaoxide, so we got 2 phosphorus, so that's going to be 30.97 times 2, so there's our 2 phosphorus, plus 16 times 5. Okay, the molar mass of oxygen is 16, there's 5 of them there. All right, so looking at 141.94 grams per mole. Okay, questions so far? How many people are done 4 and 5? Okay, so number 4 is a bit tricky because we got again a polyatomic ion here, but we did one like this previously, right? So there's 2 nitrogens in here, so we're going to have 14.01 times 2 plus 8 hydrogens, so 8.08, plus 1 sulfur, and 4 oxygens. Okay, so 28.02 plus 8.08 plus 32.07 plus 16 times 4, 132.17. grams per mole. Okay, and then on our last one, I can't remember the mass of scandium, 44.96 times 2 plus 3 carbons, so 12.01 times 3 plus 9 oxygens, so 16 times 9. $224.99 for that one. Grams per mole. Okay, everybody all right with that? Now, is it a little trickier if I give you the name of the material in words? Yes. You'd be surprised. Like, I'll do this. I've even done this on a test and just said, what's the molar mass of calcium chloride? And I'll get people who will go 40.08 plus 35.45 and think they're done. What's wrong with that? Well, no, if they did add them. Not even so much that they're in the wrong order, but calcium chloride is?
There's 2 of them. 2 chlorides.
Right. CaCl2. Okay, people just forget to write the formula out and do their drop and swap, and they just go with the words, and they get it wrong because they forget it's an ionic compound, there's going to be 2 chlorines, okay, little things like that. So it's a bit different if I give you the name in words, okay, because you have to remember to do that drop and swap. It's a simple thing, okay, not like any of you would screw that up, it's just that people forget to do it. All right. So, if we're looking at the mole, okay, and using the mole equation, using the mole, okay, what you eventually will use it for is in Chem 20. You'll use it for something called reaction stoichiometry. Reaction stoichiometry allows you to calculate in grams or moles, okay, how much product you would have based on a reaction. So if I'm trying to make ammonia, which is used in fertilizer, okay, and I want to end up with, let's say, 2,000 kilograms of it, okay, I need to figure out, all right, if I'm going to have 2,000 kilograms of ammonia, how much nitrogen and hydrogen am I going to need to have as my raw materials in order to make this compound? Because it's not 1,000 kilograms of each. They go together in a 3-to-1 ratio, and nitrogen's way heavier than hydrogen. Okay? So even though I'm gonna need like more moles of hydrogen, I'm gonna need way less mass of it because hydrogen's really light and nitrogen's really heavy by comparison. So being able to do reaction stoichiometry allows you to calculate amounts of things on either side of the equation based on either what you have or what you need. Okay? We're never going to do full reaction stoichiometry in Science 10, but we are going to do the basis of it, which is mole calculations using n equals little m over big M. And we just learned how to calculate n. Okay? We use our periodic table for that. We add the molar masses of the elements together, okay, and we get the molar mass of our compounds. So when we look at a reaction, okay, we could look at it in a number of different ways. We could say that there are 2 atoms of nitrogen, or 1 molecule of nitrogen, reacting with 3 molecules of hydrogen, or 6 atoms of hydrogen, to produce 2 molecules of ammonia. Would I ever notice that reaction if I was talking about 1 molecule of nitrogen and 3 molecules of hydrogen making 2 molecules of ammonia? Would I ever even see that? Never. That's an incredibly small amount of stuff. Okay? I'm never going to even be able to observe that. All right? But if I said it's 1 mole of nitrogen, now we're talking about 28 grams of nitrogen. I'd probably be able to see that. Okay, and move it around and be able to actually use it. Okay, and I'd be talking about 6 grams of hydrogen. Okay, and that would make 26 grams of my final, 34 grams of my final product. Okay, everyone kind of follow me there? Okay, so I could look at it that way. I could look at it in terms of moles. I could look at it in terms of mass. Okay, there's all kinds of different ways to interpret these chemical reactions, and that's also why it's important that we balance them. Okay? If they're balanced, it'll make sure that I have 34 grams of reactants and 34 grams of products, and thus obey the law of conservation of mass. So the whole reason we balance is to keep this stoichiometry, number of moles, amount of mass, always consistent. Okay? All right, so we can talk about particles. We looked at that. Okay, we could talk, well, this is Avogadro. Does he look like a mole? You ever seen a mole? This is what a mole looks like. Okay? Kind of got like the sunken eyes that are kind of big, and like shoulders that like are really sloped back because they got to dig through the ground. It makes it easier for them to dig. I bet you his nickname was Mole. Okay? You know, like affectionately, not bullyingly, like affectionately, but this guy's a mole. Totally a mole. Okay. Now, before we move on, though, we have to have a little fun. Okay, so as we said, we could talk about this in terms of particles. We could talk about it in terms of moles. We could talk about it in terms of mass. Okay, it all depends on. There's lots of different ways to look at a reaction. Some ways are appropriate in certain situations. All right. So, what we want to look at is using the mole equation. All right. So the mole equation is number of moles equals mass divided by molar mass. Okay, so if I have 4.04 grams of hydrogen, that's my mass. Okay, what's the molar mass of hydrogen? 1.01 if I'm talking about atoms. What if I have a molecule of hydrogen? 2.02, right? Because there'd be 2, right? This is 1.01. H2 is 2.02. Okay, if I have hydrogen gas, this is the stuff I'm dealing with. Okay, so the molar mass would be 2.02. How many moles do I have? 2. Okay, I have 2 moles of that stuff. Okay, because I'm dividing grams by grams per mole. So the grams cancel, and left is the number of moles. All right? Everybody kind of follow what we're doing there? Okay, so that's obviously the first way that we could use this equation is to calculate the number of moles, n. But I could also use this formula to calculate mass if I had the number of moles and the molar mass. So let's say I know that I've got let's say, something easy. Let's say I've got 50 grams, no, sorry, I'm looking for mass. Let's say I've got sodium, okay, and I know that I have 3.5 moles of sodium. What's the molar mass of sodium? From my periodic table.
0.9.
Nope,
22.
22.99. Okay, grams per mole. That's my molar mass. Okay, so I know big M and I know N. I want to solve for little m. How do I get little m by itself? Isolate it. Okay, how do I isolate it? How do I get little m by itself? What do I have to do with big M? Multiply it. Okay, basic rules of algebra are as follows. First rule of algebra. If I want to move something, I do the opposite operation. Okay, right now I'm dividing by big M, so if I want to move big M to the other side, I multiply, because multiplying is the opposite of dividing. Everybody okay with rule number one? Okay. Rule number two, what I do to one side of the equation, I must also do to the other. It's the golden rule of algebra. Okay, so I multiply both sides by big M. Okay, it cancels there. Then I multiply big M on this side. Now little m is isolated. Okay, and I can solve for it by simply multiplying 3.5 times 22.99. Okay, which makes sense. If I want to calculate the mass of 3.5 moles of sodium, naturally I should multiply the mass of 1 mole by 3.5. And that would give me the total mass. Okay, everybody with me there? All right, now you don't have to admit to this, but I'm sure that there are people out there who just finished drawing this. No, wait. See, I can't even do it right because I hate triangles. You would have drawn it like this. Little m and big M. You don't have to admit to it, but probably some of you did it. Scribble it out right now. Pretend you never did it, and I won't get angry. I know that some well-meaning teacher somewhere along the way taught you this little trick about triangles. Like,
Why do you hate it?
because I'm a physics teacher and this sucks. This is not how you do algebra. Here's why. This is a formula we're going to use in Science 10 later on. Do you have a triangle that'll work for that formula? No! Because triangles suck. They only work for 3 variable formulas like this one. Now granted, that's all you've ever learned up until now. So this teacher was, understandably seemed brilliant for showing you this triangle. It has crippled your ability to do algebra, which is bad. It's very, very bad, okay? Because in Physics 20, you're going to use this formula. I don't think you have a triangle for that one either. And like a rhombus isn't going to work either, okay? There's no shape that will make this formula work, okay? Or when you get to this one, F1 equals F0 times V plus or minus VO over V plus or minus VS. Forget it. Triangle won't work. Okay? The triangle works for simple 3 variable formulas, and that's it. All right? You cannot use a triangle for anything else. So you might as well learn to do algebra. It's not very hard. Okay? Like, guys, I make it look like I can do math. But math is not my strong suit, okay? I'm not going to say I'm bad at math, okay? Because I don't believe anybody's bad at math. That's something you've been taught, okay? Unfortunately, there's like this cultural thing about everybody's bad at math, math is hard, which is terrible, okay? You're fundamentally, like innately, good at math. But you've been taught that math is hard, and thus it becomes like a self-defeating prophecy. Okay, math is hard. I'm not good at math. I can't do math. Math is hard. Okay, and so yeah, the cycle repeats itself. Okay, and then you have well-meaning teachers along the way who teach you tricks, which reinforces the idea that you're bad at math, which is not true. But this says, hey, look, I realize math's hard and you suck at it, so here's a trick that will only work until you're done with my class, and then you're screwed. But that's not my problem. Okay, so yeah, I don't want to do that. I just can't in good conscience. Plus, I have to have you be able to manipulate that equation later. So I'm going to teach you the 3 rules of algebra. These got me through university physics. Okay? They won't help you with calculus. Yeah, I don't even begin to understand that. Okay? I never understood a bit of it. I passed the course, but I never understood anything past the first day. I memorized all of the examples in the textbook, and I wrote them down on the final exam and got part marks for method. I don't recommend that. That was out of sheer desperation. And I was really lucky. It was graded on the curve, and half the class was even dumber than me. Okay? Yeah, so I like surfed the curve on that class. Okay? So yeah, I don't recommend doing that. But learning the 3 rules of algebra, see, I almost said, that's how bad I am at math. 3 rules of algebra, 3, okay, are very simple. Okay? First rule of algebra, if you want to move something, perform the opposite, P form, perform the opposite operation. You might want to write these down. They're not in your notes. Okay, so if you want to move something, perform the opposite operation. Second rule of algebra. What you do on one side of the equation must be done to the other. We'll only need those 2 rules for the mole equation, because it's only a 3 variable formula. Okay? But there is a third rule that we'll use when we get to physics. And that third rule is move what is not attached to what you are isolating first. Okay? As I said, those 3 rules got me through university physics. And I did pretty good in university physics. Okay? But you don't have to be good at math to be good at physics. I teach physics. I'm not particularly good at math. Okay? Like if I was to sit down and try and do what you're doing in Math 10C right now, I would struggle. Okay? The whole like factoring and quadratic equation and stuff like that. Like I know the words, but I don't understand how to do it. Okay? But I teach physics. Okay? So in a lot of science, there's a bit of math, but what's more important is your understanding. Okay? The math of all the high school sciences, at least, and even into university, is linear. It's not calculus. Okay? So you can do it with simple rules of algebra. These 3 rules. Okay, so I'm going to show you an example because with the mole equation, okay, with this, we only ever have to manipulate it one way. Okay? We only ever have to manipulate for little m. We're going to solve for n, it's already set up for that, and we'll have to manipulate for little m. And that just means multiplying big M over to this side, and that's it. We never have to use the equation to solve for this, because we get this from where? From the periodic table, okay? So that's the only manipulation you're ever going to have to do with this formula, is to move this over here and multiply, that's it, okay? So it's easy algebra, you don't need a triangle for that, okay? But what if I gave you this equation, and how many of you are taking math right now? Okay, you're going to use this equation in math, and you're going to use it later in Science 10. Okay, this is the graphing equation. Okay, right now it's set up to solve for y. But let's say I want to isolate or solve for m. Right? So in order to solve for m, I'm going to have to use all three of the rules I just wrote down. I'm actually going to use rule 3 first. I'm solving for m. What's not attached to m right now? b. So I'm going to move it first. Okay? Right now, I'm adding b. If I want to move b to the other side, what do I have to do? Subtract. All right. So I subtract b. b's gone. But I have to subtract b from this side. All right? y minus b equals m times x. All right. I need to get m by itself. What do I do with x? Divide it. Right? If I want to move something, I do the opposite. Right now I'm multiplying by x, so to move x over, I divide by x. Boom, I just solved for m. Okay. And it doesn't matter how complex the formula gets, it's the same three rules. Okay? Formulas can get really complex, but you just follow these three rules and you move one or two things at a time, and before you know it, you've isolated what you're looking for, okay? And you didn't need a triangle to do it, because triangles suck. Okay? Don't let me see a triangle anywhere in your science stuff, or I will become enraged. That's not good.
What if it's not a triangle, it's just like one line?
Yeah, I'll still know what you're doing, and I know you're better than that. I wouldn't bother teaching you algebra if I didn't care about how you did in anything algebra related later on in your life. Okay? So it's important for you to learn how to do it properly. Okay. All right. I want you to copy that down. We're going to walk through it as our first example of a mole equation calculation. So whenever we have a problem-solving question, be it in chemistry or physics, the first thing we want to do is write down what we call our givens. That is, what quantities does the question tell us? All right, so this question says, how many moles? All right, so that means I'm looking for n, because n is the number of moles. Okay, so how many moles of calcium chloride? All right, what can I calculate with that? If I know the material, what can I calculate about it? It's molar mass, that thing we learned how to calculate a few minutes ago. Big M. Okay, I know it's CaCl2, so that's going to be 40.08, that's our 1 calcium, plus 35.45, our chlorine, times 2, 110.98 grams per mole. I didn't just do that in my head, I memorized it. Okay. No, really, I've used that one so many times, I just know it. All right, okay, so I've got big M, and then they tell me are in 90 grams. What does grams measure? Mass, little m. Okay, on a quiz or a test, you would get a mark for this. You would get 1 mark for your givens. Okay. Writing down our givens, not really as important in chemistry as it is in physics. In physics, you're going to have like a page of formulas. And writing down your givens helps you to decide which formula to use, because you just have to look and go, okay, I have these 4 things. That formula has these 4 things, that's the formula I'm going to use. In chemistry, we only have 1 formula, so it's obvious, but you still get marks for writing down your givens. Okay? Now that I know these givens, I know I have to use this formula. n equals little m over big M. Depending on the question, I might even give a mark for that in physics. In chemistry, because it's our only formula, it's kind of obvious that that's the formula you're going to use. Okay? Now, in this case, do I need to manipulate the formula? No, it's already set up to solve for n, which is what I'm looking for, so all I have to do is plug in my numbers. If you did have to manipulate it, there would be an additional mark for your algebra. Okay? Right now, the mark you're going to get is for plugging in your numbers correctly. 90 divided by 110.98. Okay? I'm putting in the units. You don't have to put in the units in your calculation, and just putting them there for clarity. Right? Alright, if I punch that into my calculator, 90 divided by 110.98, so I have 0.811 moles. And we abbreviate moles, mole, because we're very busy. We don't have time to write the whole word mole.
What would the mass always be grams?
Yes. Now, a question might give you like 2 kilograms, you would have to convert that to grams because our molar masses are all in grams per mole, right? So mass, when you're calculating it, has to be in grams. If you're given it in anything else, you have to convert it to grams. It's a good question. Okay, everyone follow what we did there? So this would probably be a 3-mark question. You get 1 mark for your givens, you get 1 mark for plugging in your numbers, and 1 mark for your solution. Okay, if that didn't have moles at the end, it would be wrong. Okay, it has to have units to be correct. All right, questions there? All right, tomorrow we're going to go over 4 examples, okay, of using the mole equation. There are only 4 ways I can ask a mole equation problem. Every day for the rest of the unit, I'm going to go over 4 examples, 1 of each way. Okay, so there's lots of solved examples before the exam. Don't forget, your labs are due tomorrow. Okay, have your labs submitted on Google Classroom at 8:30. That's when they're due.